My name is Darren Thomas, and I am the Director of Educational Research Techniques. This is easier, practical applications of machine learning algorithms in R. And we're now finally going to do our classification model using support vector machines. In particular, we're going to use a linear kernel model. We're going to develop the model and test it in the same video. So let's go ahead and move over to RStudio. So we're here inside RStudio, and I need to remind you that you need to run the packages from the prior video of lesson unit 5-2 in order to have the function that you need for this video. So just as a reminder, you're going to need to load the Kernal lab package as a minimum, but also, if you don't mind, the mass and the core plot as well. So here we are. You can see in line 2 that I'm setting up my model. I call my model classify. Inside classify, I'm using the KSVM function. So I already brought up the information, but if you want to learn more about the KSVM function, you just type KSVM, type enter, and then the computer pulls it up for you right here off to the right. So I'm going to talk about it in a second, but let me finish walking you through what's inside the parentheses here in lines 2 and 3. So our dependent or our predictor variable, our outcome variable is going to be type. And so then we have the delta sign there, which is right next to the number 1 on your keyboard, and then we have a dot. What that dot means is that we want R to use all the variables inside the training scale data set. We want to use all of them to try to predict the behavior of the type variable, the dependent variable. And after we talk about the data set, I just kind of mentioned that. In this third line, in line number 3, we have the kernel. Remember we talked about the kernel trick where it will kind of make features to try to better predict everything. There are many different types of kernels. In this particular video, we're going to use something called a vanilla dot kernel, which essentially is a linear kernel. And again, now I want to talk about over here off to the right here, if you don't mind, right here, about this. So let me zoom in so we can learn more about these kernels. So this is all the documentation for the KSVM function, support vector machines from the Kernal lab. And so down here at the bottom, let's see here, where is it? We have, right here, the kernels. So these are all the different type of kernels. RBF dot, poly dot, vanilla dot is what we're using right here. Tonnage dot, Laplace dot, Bessel plot. Again, if you're familiar with calculus, this will be much easier to understand and appreciate. Essentially, the linear kernel is just going to draw lines to separate the data. That's what it's going to do. It's a very, very basic plot. Basic kernel, but there are all these other ones. Which one to use kind of is up to you to try to figure out whatever works best, but we're going to use the linear kernel or the vanilla dot kernel. So having said that, we're going to go ahead and run our model now. That's in lines 2 and 3. Press Control Enter, and it's done. So I'll go ahead and show you what it looks like. And so you can see the parameter we have to set is called C. This is called a hyperparameter. When we get more into how to adjust models, we'll talk more about that, but right now it's set to 1, and you can change that if you want. And then here it tells you the type of kernel we use, which was of course linear or vanilla. I guess vanilla kind of means like boring. Maybe that's kind of a joke by the coders. And then the number of support vectors. Remember, when we talk about the number of support vectors, we're talking about how many people are right there on the margin. So in this example, 103, then it has the objective function value and the training error, 23%. Which means that it got about 77% of it correct. That's what's happening there. And we can verify that by looking at the table here. So in lines 5, I have the table. You can see here, I have 115 nodes that were correctly predicted and classified as nodes, 39 yeses, and then I had some off-diagonal stuff here. And if we were to actually calculate that, which I guess I should go ahead and add that to make it easier for us in the future, I'll add that right here. Do the double equal sign, use the mean function, 77% like I just said. Now there's something I need to mention that I kind of glossed over because I'm so familiar with this. Let me show you something. If you look closely at the classify object we made, instead of using the dollar sign, we use the @ sign. Now I don't know exactly why, but this object has a different type of behavior. So when you make your support vector machine object, you have to use the dollar sign and find the fitted if you want to try to create the table. If you don't care about the table, this does not apply to you. But notice how in lines 5 and 6, I had to use the @ sign. This is when you press Shift and the number 2 on your keyboard to access this information. the dollar sign will not work because the behavior of this object is different. But you can see over here for my training scale data set, I still use the dollar sign. So I just wanted to point it out because I kind of flew by that, but I'm trying to help people to learn how to do this so I cannot skip steps. Now in line 6, you can see I did the same thing here. I used the dollar sign to access the fitted information, and then I was able to calculate the accuracy as well. So just want to make sure that's clear. So let's go ahead and zoom out again. All right, so we know the performance of our model on the training data. We want to now see how it does on the test data. So in line 8, I am using the predict function, something we used before, and we're going to use our object classify, that's our model, and we're going to use our new testing data. So we just run that real quick, and then we just click table again, and you can see we have the results right there. And also we can run this again, and you can see 79. So we actually did better on our testing data. Somewhat surprising, but 2%, not that bad. So you can see that this is kind of how things work. One thing I forgot to mention was you got to set your seed, of course. So if you set your seed to our trusty friend 10, which I think I did that before the video, you will see that you'll get the similar results hopefully. If not, set your seed accordingly so that you can get the answers. So having said that, I think that we finished with our training and testing of our classification support vector machine model, and you can now use this information to train and test your own models. So in the next video, we'll use a different kernel for a different purpose. My name is Darren Thomas. I am the Director of Educational Research Techniques. This is easier, practical applications of machine learning algorithms in R. Take care.